Hello friends. Today we are going to learn about cotter joint. Now let us see what is cotter joint. It is basically used to connect two rigid rods which transmit motion in axial direction without rotation. These joints may be subjected to tensile or compressive forces along the axis of rod. Joints may be temporary or permanent. Most types are designed to be disassembled. Cotter or wedge passing through the hole fix the parts tightly together. The application of cotter joint is connection of piston rod with the cross heads, joining of tail rod with piston rod of a wet air pump, foundation bolt, connecting two halves of a flywheel. These are the most common applications for the cotter joint. First, let us see the parts of a cotter joint. The most important part is the cotter, due to this part, the name for the joint is given, hence the cotter joint. Now there are three other parts as well. This is known as socket, inside which the spigot end inserts, and the spigot collar is the part which is at the end of the spigot end and connects to the rod, and it can be used for tensile or compressive loading. Now let us start with the design procedure of cotter joint. Now let us begin. First thing, now for the step number 1, we will design the rod end. Now design of rod end is basically the design of these two rod ends. These two rod ends. We will find out its diameter for the applied loading. Now let's start with the design procedure. For this we will take the cross section of the rod, which is always circular, with the diameter small d. Now since we are considering tensile loading, so the strength of the rod under tensile loading we will find out its tensile strength. Due to tensile loading there will be tensile failure, hence tensile stress or tensile failure will be considered. We will take the well known formula for load equals stress into area. Now this is the formula we will use for almost every step. Here loading, which is equal to tensile stress into area, which is obviously pi by 4 into d square. This becomes our equation 1. With this equation we can find out d, or tensile stresses can be calculated. Now for step number 2, this is for rod end, this much is enough. For step number 2 we will design the spigot end. Now, taking the 3D view of a spigot end, it almost looks like this. We are considering tensile forces, hence the arrow will be in opposite direction going away. Now considering failure of spigot under tensile. In step number 2 we will take point number 1. Considering tensile failure, so for here we will take its cross section from its weakest part, where the slot. Now as you know, the weakest portion of a mechanism or a component is where it has a slot or a hole. So here we will consider this cross section area. Cross section area AA. For this we will draw a 2D diagram. This we will consider as D1, the diameter for the spigot we will consider as D1, and this is for the thickness T. Now this is our resisting area. Now let's design it. Once again the same formula. Now for this the area will be considered as such. Here it will be pi divided by 4 into D1 square D2 square minus, we will take this rectangle, the area of this rectangle, which is D2 into T. So this becomes our area. So this is how our formula will turn out, into pi divided by 4 D2 square minus D2 into T. This becomes our equation number 2. From this, D2 or tensile stresses sigma T can be calculated. Now for part number 2, for this step 2 will be like this. Now we will consider shear failure, how the shear failure will act. So as you can see, in this hole the cotter will be inserted. Now this cotter will pushing this portion outwards. This portion outward. So we will find out the area of this portion. So let us begin with the part number 2 for the step number 2. For here we will consider shearing failure. So the shearing strength will be considered. Let us draw a 2D diagram for this. It will be basically a rectangle with the longer side as D2, and this will be A. Since here we have considered this portion, this much portion will come out, so this much length we have considered as A. Now let us calculate. For here we will find out shearing strength. For this we will use tau instead of sigma T. This is our resisting area. Now let us combine it. Now area will be 2 into D2 into A, since there is another surface behind it. As we have drawn here, there are two surfaces. One we can see in front, the other one is in the back side. So there will be two surfaces, so we will take two areas. This is how we get equation number 3. Now let us go further. Now for part number 3, here we will consider crushing failure. Considering crushing failure. So in crushing failure, what will happen basically is that there will be surface contact of the cotter with the inner portion, with this inner wall of the hole. So there will be a formation of powder. So let's check its 2D diagram. How will it come? Take this diameter as D2, and this is the hole where the crushing will appear. This is the thickness with T. So the resisting area becomes A equals D2 into T. So for equation number 4, our formula will become something like this: crushing stresses into D2 into T. This is for our equation number 4. From this we can find out crushing stresses, which can be calculated or checked. Now for step number 3. For step number 3, we will design spigot collar. The spigot collar, this portion, will be designed in step number 3. For this we will consider shearing failure. Now why shearing failure only? It's because if there is a compressive forces. Now if there is a compressive forces, what will happen is that this round collar thing will come out and become a ring. With thickness T and diameter will be taken as D3. This will come out due to compression or maybe due to tension. We will get a ring. So design of spigot collar is also very important. Let us design it. We will consider shearing failure. Considering shearing failure into area, now the area will be somewhat like this. This is our collar, and this is the resisting area with thickness T. This is our resisting area. So how we will find out our area? Area will be pi d2 into T, circumference into T. So this will be our formula number 5. From this formula we can find out T. T can be calculated. Now for step number 4, we will design socket. Now socket is the part in which our spigot end has been inserted. The design of the socket, as you can see in this diagram, this is known as the socket. For step number 1, once again there will be three points in step number 4. Just like the spigot end, we will find out considering tensile failure, so our cross section area will look something like this. Since the maximum chances of failure of socket will be nearest to the slot or the hole where the cotter has to be inserted, this is the portion where the socket is the most vulnerable. So let's design this part. For tensile strength we will consider, now this has become our resisting area. With dimensions as d1 and with the inner diameter as d2, same as the diameter of spigot. For this the area will become pi by 4 d1 square minus d2 square minus d1 minus d2 into T, means we will subtracting the area of this rectangular of this whole portion from the area of the ring. So our formula will become somewhat like this. This becomes our formula number 6. Now in step number 4 we will go for part 2. Now part 2 of spigot end will be shearing failure of socket. We will consider shearing failure. Considering shearing failure, for this our 2D diagram will look something like this. So just like in the spigot and we have considered shearing failure, the part which comes out due to the force, to the opposition of force of the cotter pin, just like that we will consider for the socket end as well. For this we will have our resisting area as D4 into D2 into C into 2, since there are two surfaces, one in the front and other one in the back side. Now C is the thickness which we have considered over here. C is the thickness which we have considered here. The same thickness we will take here. Now formula will become somewhat like this. Force is equal to, loading equal to 2 into D4 minus D2 into C into tau. This is our formula number 7. From this equation, D4 or C can be calculated. For part number 3 of step number 4, we will consider crushing failure, just as we have considered for spigot. Considering crushing failure, our resisting area will look something like this. This is our resisting area. We dimension the major diameter as D4 and smaller diameter as D2. The area will become, resisting area will be D4 minus D2 into T with thickness as T. Once again we will find out crushing strength for socket. D4 minus D2 into T. From this equation number 8, sigma CR or crushing stresses or D4 can be calculated. Now step number 5, we will design cotter. Now since the cotter, we will consider shearing failure. Now why is that? Because the spigot and the socket will try to divide this cotter into 3 portions, 2 for the socket and 1 for the spigot, where B is its mean width. Now let us see how will it look. For this there will be double shear, one here and another in below this surface. For this the resisting area will be A equals 2 into B into T, where B is the mean width of this cotter pin. For 2D we will consider somewhat like this, where its thickness will be T and the mean width as B. Now let us calculate shearing failure. Considering shearing failure, P equals tau into 2 into B into T. This becomes our equation number 9. From this equation, B can be calculated. So friends, that's all for today. We have completed our design procedure for cotter joint. Now let us take a brief For step number 1, we have designed a rod end, finding its diameter or tensile stresses. We have considered tensile loading, failure under tensile loading. For step number 2, we will design spigot end. For spigot end, point number 1, tensile failure has been considered. For this, our resisting area is something like this, and our formula becomes P equals tensile stress into pi divided by 4 into d2 square minus d2 into t, where we are reducing the area of this rectangle from the whole circular cross section. From this formula, d2 or sigma t can be calculated. For step number 2, point number 2, we will consider shearing failure. For shearing failure we have considered, because this cotter inserted in this hole will try to force this much portion away out of its body, due to which shearing will occur. So the shearing failure we will consider where resisting area becomes 2 into d2 into a, because there are two surfaces, one in the front, another one behind the surface. A is the width we have taken first hand in our diagram. This A is the width, and d2 is the diameter of spigot. So our formula becomes P equals tau into 2 into d2 into A. Now point number 3, considering shearing failure. Now shearing failure will happen due to the surface contact of cotter pin and the spigot end. This will cause the formation of powder, which is another failure. For crushing failure, our formula has become loading equals to crushing stress into d2 into t, where t is the thickness of cotter. From this, sigma cr can be calculated or checked. For step number 3, we will design spigot collar. Now in spigot collar, first we will consider shearing failure. Why shearing? Because in compressive forces, the spigot end will try to come in this direction, causing this collar to slip away, to break away, making a ring just like this. And this is our resisting area, and area becomes pi d2 into t. So our formula becomes P into tau into pi d2 into t, where t can be calculated from this formula. Now for step number 4, we will design socket. For first we will consider tensile failure. Tensile failure, we will consider the cross section area at which the hole is present, because the hole will make this this is where the socket will become more or the most vulnerable, causing it to mostly break at the part where there is a hole. So here our formula becomes P equals tensile stresses into pi by 4 d1 square minus d2 square minus d2 minus d1 minus d2 into T. This is our equation number 6. From this, sigma T can be checked or T can be calculated. Now for step number 4, we will go for point number 2, considering shearing failure. Just like we did in spigot end, this becomes our resisting area, where C is the thickness we have considered over here beforehand in our diagram. This C is considered over here. So our formula becomes P equals 2 d4 minus d2 into C into tau. Here we have multiplied by 2 since there are two shearing surfaces, one in the front and another one in the back. From this equation we can find out D or C. Now crushing failure, once again just like in spigot and we have considered, for socket we will also consider crushing failure. So formula becomes P equals crushing stresses into d4 minus d2 into T, where sigma CR or crushing stresses can be calculated or checked. Now step number 5, which is the last step, we will design Cotter joint. For this we will consider shearing failure, and our formula will become P equals tau into 2 into B into T, since there are two surfaces, one at the top and another one in the bottom. From this, B can be calculated, where B is the mean width of the cotter. That's all for today. This was the basic design procedure for Cotter joint. This is Shizan signing off for today.